Hello, everyone, and we are back again. So, we will continue with the learning Odin and continuing with this official documentation of Odin. We last time covered till the advanced type, so today we will be starting with the advanced types in Odin. And the goal is to quickly cover this stuff so I can start like building cool stuff using Odin, and the upcoming streams I guess will be more interesting for that. Yeah, so let's just see. Everything is fine. Everything seems fine. Everything seems working. And what do we want to do now? Okay, so let's start with the advanced types. So we have type alias, so you can create your own types. You can give alias something like this. So my int is int, assert that my int is equal to int. Okay, let's move quickly through this section. An array is simplified fixed length container. Each element in an array has the same type. An array's index can be an integer, character, or enumeration type. An array can be constructed like this. So this is a fixed size array. You put like 5 over here. So there are 5 elements in this array. And you can do something like this, but this 4 is hard coded. So let's start with writing some code, I guess. Okay. So we create an array. Integer. You can create it like this. Okay, so what's the syntax? It's kind of similar to like the Go syntax, I believe, and yeah, it's kind of similar to that. So we give size of the array, and then we give integer and the elements of the array. 5. For a in ARR, we can do this thing, and from dot print line a. So we get all the elements. I believe we can do something like this for I, or yeah, for I in uh, equal to the length of array until cleared name a, which is correct. And this is equal to, so it will go out of bounds, I guess. Yeah, it is out of bound. Index 5 is out of range. Okay, so we do less than this, and now we are good to go. Okay, so this is how we create fixed size arrays are equivalent to a struct with a field of each element. They are just a number values in row in memory. The notation exercise is used to access this. The above array can be constructed with question mark automatically infer its length. Okay, so they are just saying that you can put the question mark here. So now if you have 5 or 6, you don't have to change. It will infer the type, right? So it will infer the type. And what else can we do over here? Construct an array with designated initializers, favorite animals, or this. Okay, assign by index. That is interesting. That is interesting. What is this stuff? Let's see this one. This seems interesting. So we have something like this. We will, yeah. Shall we we are back now, and let's continue with this thing. We have favorite animals, which says string, and okay, this is weird. This is weird. So 3 to 5 it says frog, and 16 less than 8. Okay, I need to print this thing. So I'll print this favorite animals. And now if we run this thing, so okay, so we get this frog. Okay. Um. Yeah. So what this thing basically does is it assigns like three uh inserts like three frog values into the array. So this syntax is something like this. This is interesting. I'm like seeing this like first time. Yeah. And do we have people watching the live stream? If you're watching the live stream, do say hi or something. That would be pretty cool. And yeah, so this is pretty cool, I guess. So close this one. I want my window. Yeah, this is the one. The built-in length proc returns the array's length, which we know. Array access is bounds checked by default, both at compile time with constant indexes and at runtime. This can be disabled and enabled per block level. No bounds check. Okay. Okay, you can remove like bounds checking also, which is interesting stuff. Hmm. Yeah, which is interesting. And array programming, Odin's fixed length array support. Okay, we have this. We can define a vector 3. And would be Odin also support matrix types. Swizzle operation. Okay, what is this thing? Swizzle. I'm not sure what this means. Let's just grab this thing and see. Okay, we have this thing. Let's just remove this thing, and we have swizzle. Okay, let's do from dot print line b. We get 30, 20, and 10. What does that do? 30, 20, and 10. Okay, are we giving the indexes over here? Is it something like this? We can check this thing. So we can do 1, 0, and 2. And now we get 20, 10, and 30. Okay, so you can give an index and then it will create a new array thingy. Okay, okay. That's pretty nice. I wonder where it is useful, but yeah, seems pretty cool. Built-in implicit swizzle fields are available on an array with length less than equal to 4. Okay. Okay. Let's see this example. That seems interesting. So we do vector 3. We have distinct keyword. I'm not sure of that. This. Okay, we do c dot x, c dot y. Slices. Okay, slices look similar to arrays, however their length is not known and compile time. The type t is a slice with elements of type t. In practice, slices are much more common than arrays. Yeah. Slice is formed by specifying two indices, a low and a high, separated by a colon. Okay, so if we have an array which is something like this of 10, 20, 30, 40, 50, and we do something like this is our slice. Do I have to give the type, or I can do something like array 124? Okay, I can do this, but I'm not printing it, so I'll do print line s. Okay, we get 20, 30, and 40. So these three elements in the slice. Again, this is how you can give the slice. Slices are like references to array. They do not store any data, rather they describe a section or slice of underlying data. Internally, a slice stores a pointer to the data and an integer to store the length of the slice. The built-in length proc returns the slice's length. I wonder what if we do s of 0 is 5? What will happen then? Okay, so it changes to 5, and if I print the array, I believe that element will also change to 5. So this element changed to 5. I'll just print it over here. So it was 10, 20, 30, 40, 50. Now it is 10, 5, 30, 40, 50. So these are references. So we have to be careful when we are using slice. Slice literal. A slice literal is like an array literal without the length. This is an array literal, right? And this is a slice literal. You do not give the size, then it becomes a slice. Okay. For the array, we can do this. The slices are this. If you want all the elements, you can do something like this. When like grabbing a chunk of slice, a offset plus length, it can be written as offset and length. Okay, offset, and it is offset plus length. Yup. Nil slices. The zero values of slice is nil. A nil slice has a length of 0 and does not point to any underlying memory. Slices can be compared against nil and nothing else. So, okay. Sorting a slice, we have slice dot sort. Okay, we have slice dot sort. Do we have to import something for slice, or how does it go? I want to try this one. So, create a slice. This is a slice. And we print this thing, we get this thing, we do slice dot sort error. Okay, slice is not found. Can we import it? We can import it. And the slice dot sort, if we go over here, okay, I believe this is not the Odin documentation. Slice dot sort Odin package slice sort. What's the sort? Sort. Can we do reverse? Can we do reverse? Reverse sort. Okay, we have reverse sort. Now it is sorting reverse. That's what I wanted to do, which is pretty cool in my opinion. Pretty cool. Okay. Next thing, what we are going to do. So I think this page is pretty nice. Pretty nice. So these are all the libraries that are there, I think. Yep. Zlib is also there. Interesting. But let's not get ahead of ourselves and let's do things. Oh, we had the reverse sort here. Dynamic arrays. So dynamic arrays are similar to slices, but their length may change during runtime. Dynamic arrays are resizable and they are allocated using the current contexts allocator. So we haven't looked at the context till now. And yeah, this is how you can define a dynamic array. Let's do this thing. And what I'll do is I'll say dynamic array of integers append and percent array. Okay, so this is the address of ARR and we had 1 2 3. Okay, cannot assign a type dynamic into ARR. The type of the value ARR cannot be assigned default type. Okay. Okay, so we need to give this as a type, I believe. And then we have 123. So this is how we can append. We can append multiple values. We can append one array into another array, which is pretty cool. Inject sign to a dynamic array. Injecting into a specific index can be done with inject. It will move other elements of words when inserted below the other elements. Assigning a type to a specific index can be done with the assign. It's the same thing as doing this. Okay. So you can inject elements in between. Right. Let's take this one. What do we get from this one? Okay. We get 10. We have the make keyword, so make dynamic integers 0 and then 16. Initial capacity is 0. Do you mean that? Injected 2. So we get 0 0 and 10. And if I do something like this, yeah, that also works. That also works. It's working. What is this e println? What is this e println? In Rust, Odin, let's see. Formatted IO with procedure similar to C's and Python's format. Eprintln. Eprintln formats using the default print settings and writes to os.standard error. Okay. So it writes to os.standard error. Okay. Assign at, yeah. Removing from a dynamic array, you can do pop. You can do ordered remove. You can do unordered remove. We have a bunch of stuff. Slices and sort a dynamic array. Although dynamic arrays and slices are different concept, dynamic arrays can be sliced and sorted as follows. So we have a dynamic array, we append, we sort. Yeah, so because it is a reference, so it will change the original array. Making and deleting slices and dynamic arrays. Length of 6. Length of 6. Capacity is also 6. Length is 0. So this is the length and this is the capacity. Okay. So if you initially know how many elements you will be assigning, you can give it a capacity to, so it doesn't have to do the relocation and rebuild the array again and again. Yeah. Within an explicit allocator, okay, you can give an allocator. I don't know what an allocator is. Clearing a dynamic array instead of deleting the array, you often want to clear the dynamic array. This will set the length of this to be 0, and while the capacity remains the same. Resize slash reverse with our dynamic array. Resize reserve. Okay. Small array. I'm skipping this small array part. I'll see it later. And enumeration types define a new type whose values consist of the ones specified. The values are ordered. For example, direction, this, then the following holds true. If we convert it into an int, it starts from 0. So 0 is north, 1 is east, south, and then west. Cool. Enum fields can be assigned an explicit value. Foo enum, and we get A, B, C, D. Okay, you can, holes are valid. You can assign a value to an enum. If an enumeration requires a specific size, a backing integer can be specified. By default, int is used as a backing type for an enumeration. Okay. Who will be only 8 bytes, 8 bits. Implicit selector expression. Okay, and an implicit selector expression is an abbreviated way to access a member of an enumeration in a context where type inference can be determined. The implied type, it has the following form dot member name. This I think we looked at. This we have done. Using can also be used with an enumeration to bring the fields into the current scope. Oh, you can directly access A if you do using. Iterating an enumeration, so you can use in, then you can print the index and the direction. Cool. Cool stuff. Enumerated arrays allows the use of an enum to be used as indices to a fixed array. We will be extending the direction enum used previously to add direction vectors. Direction is this. Direction vectors is in two-dimensional array. Direction and integer. This is interesting. This is interesting stuff. Hmm. The partial directive can be used to initialize an enumerated array partially. The sparse directives can be used to initialize an enumerated array with an enum, which does not have contiguous values. Array is this integer. Hmm. Without partial, the compiler would complain. Yeah, makes sense. Bit set. So the bit set type models the mathematic notation of set. A bit set element can be either an enumeration or a range. So we have a direction, we have a direction set, bit set, direction, character set. Okay. Hmm. That doesn't look that interesting to me. I'll move on to the pointer section. So Odin has pointers. Pointer is a memory address of a value. The type caret. This is called a caret, right? Not carrot. Uh, yeah, this one. See, caret. So caret symbol defines a pointer. That's interesting. They don't choose asterisk. So p integer, and then we get this. So basically, what you can do with this stuff is you can do something like this. Create a you can create like an integer, and then you can say p is pointer to x. And now if you print line the x and p, you'll get the memory address. Okay, p cannot. Okay, this is going to be ampersand over here, right? So this is the memory address that we have of p. I'm pretty sure you can like dereference this to get the value. What is the dereferencing operator then? I'm not sure. What is this thing? Ooh. Okay, so this is after. I was putting it before. Okay. So this is the address and then you could dereference it. This makes sense. That makes sense. A struct is a record type in Odin. It is a collection of fields. Struct fields are accessed by using a dot. So this is a vector 2 you can define. Let's define vector 2, which will be a struct, and we'll have two fields, f32 y f32. I think they give like preceding this thing commas, right? Different for like splitting it into different lines, I guess. So we do vector 2, and then you can give the values, right? And then you can print this vector 2 using from the print line. And let's see, let's run it again. This is a weirdly long compile time. Need to run it again. Okay. I don't know what happened there. And we get like vector 2 x equal to 1 and y equal to 2. Right. And we can do a lot of things with pointer. Ooh. 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 So we can do something like this. I don't get that. So okay, I'm going to write something stupid. What we'll get here. We say we have a pointer to this. And then we say we get this and get one. Yeah, I did it. I did it. Okay. Okay. Struct literals. A struct literal can be denoted by providing the struct type followed by this thingy, which is fine. This is a vec3. Also, I think you can write it something like this. Leave. Yeah, which is pretty cool. Pretty cool. Okay. You can have nested struct. You have packed structs as well in this thing. Remove padding between fields. I don't know. This stuff we might look at later. Because this can be interesting while like parsing some file formats like PNG or something like that. Struct field tags. We have a struct field tags. Untagged field. Ooh. This is very similar to Go's stuff. So Golang has this serialization kind of a thing. Yup. And coding, yeah. I know this. Then we have union. A union in Odin is discriminated union, also known as tagged union or some type. The zero value of a union is nil. Hello. Hello. And type assert that v is of type strict, otherwise panic. So you can do type assertion. V is a string. We can give this okay thing. Type switch statement. A type switch is a construct that allows several types assertions in series. Okay, you can give v in value. Not that interesting to me, at least. Union tags on. Okay, maps. Maps are interesting stuff. Can make a map, and in order to make a map, what you gotta do? You gotta create a map. It's a keyword. You make a map which will be a string keys to an integer value, right? We differ, delete the map because we don't have garbage collection and Odin manual memory management for a reason. I'll write my name is 69. And what else can we do using this thing? Can we print the entire thing? We can. And can we access it using this thing? I don't know. Yeah, we can. So this is pretty cool, I suppose. You can check if a key exists in this. So if you can do want to in my map, the true. Yep. Yes. You can define a map like this as well. Interesting stuff. Okay. Mm, from dot println Bob. Procedure type. A procedure type is internally appointed to a procedure in memory to nil in the zero value of procedure type. We've learned about procs, I guess. You can pass proc, you can pass functions. Okay. That is amazing. Hmm. Type ID is a unique identifier for an Odin type. Okay. The constructor is used by the any type to denote what the underlying data type is. Hmm. Is an any type. Multi-pointer. I'm skipping this stuff. Structure of arrays. I don't see anything like super interesting here. Like any matrix. Okay. This might be interesting. So you can do something like M is a matrix of, or you can simply do M is a matrix of 2 comma 3 and the type is f32 1 9 like this maybe 1 9 minus 13 25 minus 6 um um hmm interesting interesting stuff. So matrix is interesting and casting stuff. Do we have something interesting? I think these are interesting stuff, but I'm like skipping them for some reason. Let's see. Raw data procedures. Not very interesting. That is using Okay. Using statement with structs. Let's take a very simple entity struct. XYZ entity is this, position is this, orientation is this. It can be used like this. Who broke entity array. I think this stuff is not very interesting to me. Let's see. Hmm. So we have or else, or else. Oh, we have or else, guys. And what we can do with or else is um like this. You gotta make a map. You gotta make a map. There was another syntax of defining a map. I'll use that. I think it was something like this. And yeah. Let's see if this syntax is fine or not. Okay. If you want to enable them, add this dynamic literals. How to make? Mm, okay. Now we have this map. We can do something like this. This is cool. We can do no, this doesn't exist, or else give me 420. Give me 420. We get 420 because this is not present. Yeah, this is a cool thing. Or else is nice. Or return. Or return. Or continue. Or break. Conditional compilation. When Odin OS is Linux, do stuff. Hmm. We have build tags. Implicit sorry. Context. You can define a context. We are on the allocator section now. Oh, I think other stuff is like pretty much you read about it when you actually want to use it. I believe that. Mm. Allocators Odin is a manual memory management based language This means that Odin programmers must manage their own memory allocations and tracking. Thing I forgot to do is defer under deletes. Was it something like this? Hmm. Hmm. I need to see the map section. Make map. Oh, I was pretty close. Yep, this is correct way. Pixel arrays. No. Where were we? We were at allocator. Where is allocators? Okay, we have the allocators over here. I should remove this no AI thing. Maybe. Can we put it like here? No. Yeah, I think it's fine. Allocator, so Odin is manual memory management based language. That means that Odin programmers must manage their own memory and allocations and tracking. To aid with memory management, Odin has huge support for custom allocators, especially through the implicit context system. The built-in types of dynamic arrays map both contain a custom allocator. This allocator can be either manually set, or the allocator from the current context will be assigned to the data type. All the allocators in Odin preferably done through allocators. Okay. Do new, can use the new keyword. Okay, so we have someone in the chat. FPS highlights 26 asks me hi. So hi bro. And are you a developer? Yes, I am a developer. So what I'm doing in this stream is I'm trying to learn the Odin programming language, and I'll be doing like few pretty good projects. I have some ideas that I want to implement and do sort of kind of like a recreational programming thing. Uh, so before you start, can you review my project name Jamify? Search on Google. I'm a dev student and I think you are going to like that project. Okay. Is this the one? Listen to music like never before. Okay. You have 50 million plus songs available, 320 kbps high quality audio, 24/7. Oh, you have users. That's great. Okay, let's get started. Okay, do we have to log in? I'll do it on the other screen over here. Hmm, just give me a minute. I'm doing the login. There's a code that will come. Okay, so I think this is your page. Let me see. Oh, that's nice. That's responsive. if you want a better user experience, then you can use Android APK if you have an Android phone. Actually, I don't have an Android phone. I have a iOS device, so I'll use it here. So, okay, you can play songs. You can search for songs, and let me search for a song from here. Let's see this one. Mm, let's see. So I searched for this song. The album comes here. That song didn't came. So what I did was I opened this. I think you call it a playlist maybe. I want this song. Okay. I guess I can't play it. I'll get a copyright. So if you search this song, this doesn't come here. A different song comes here. Okay, let's do songs. Okay, here it comes. In all, it doesn't come. Okay, you say go on the search tab. Okay. In songs, if I do this song comes on top. On all, there is a different song that comes on top. Yeah, I think you can fix this thing, this one thing. Oh, so I'll move on to the next. Let's discover. So we have liked songs. I believe you can. We have one thing I'll do before I move on further. I'll mute the sound. Yeah. Right now it's under development. Yeah, it looks pretty good. So did you actually like coded it? Did you use AI with for this? What is the front end and the back end looks like? I believe I can look here. So you're using JavaScript. You're using which framework? Hmm. Click on the current playing song to open full screen. Okay. Yeah, we have the full screen over here. Yep. It's nice. I can like this probably, and then this comes into my liked song. So this is like Spotify, I guess. We get one songs over here. My playlist. Let's create a playlist. Hmm. Find music to add. Let's say I want to add this to my playlist. Okay, so it got added in my playlist. This is my playlist, and we have the song over here. And also, there is a mic on full screen to get lyrics. There is a mic. Yeah, there's a mic. Okay, this song doesn't have lyrics. Let's see some other song. Okay, this we go to the artist, which is cool. There is a main feature that you can import your Spotify playlist directly into the app. Wow, that's really cool. So where is that feature? Discover my playlist probably here. So import Spotify. Yeah. Yeah, it's cool. It's nice. Go to music and we go to this one. I clicked the artist by mistake. So it says artist not found. Let's see. Do we have lyrics for this one? Try searching for another song. check the lyrics my playing the song. So I tried for lyrics for a few songs. Okay, wait a minute. So if I pause this and I do this, okay, I can load the lyrics. Can I click this and will I move to that position? Hmm. Okay, it's probably playing. I don't have sound on. Okay. And then if I go here, okay. So this goes further. Play the song and see the lyrics. Yeah, I am able to see the lyrics. This is pretty cool app. This is nice. I was looking at this thing. So for front end, you have used Next.js, React, Tailwind, Redux, Icon. For backend, you are using Next.auth.js. How good it looks and it follows the song lines. Yeah, that is pretty nice. That is pretty good. So yeah, I was asking you, how did you create this? Did you use any AI tools for building this thing? Did you do it yourself? How was it? Okay, till the time we catch up, and I can see through your next.js you are using MongoDB. Okay, okay. I want to see some of the backend stuff. You have the data in here, the models. It says message redirected. Your last message didn't go through. What was it actually? Hmm. Where is the backend of this stuff? API? Okay, we can download. Yes, I used AI 40 to 50% to understand how things work. Okay. Okay. I actually have no AI. You can see over here. No AI. But that is for me. I want to see some of your Mongo stuff. So is the backend also in this particular thing? Because I haven't worked with Next.js or something. What are you using on the backend? Next.auth.js, MongoDB goes. So where is the backend code? Can you guide me to that? Because I'm not able to find it. App API liked playlist check. Okay, what do you do? Connect DB. I want to see Connect DB. Okay, so lib. Where is your lib folder? Okay, so you have lib and you have your MongoDB stuff. Are you a dev student? No, I'm not a student. I work as a software engineer. Hmm. Okay, you have your MongoDB URL in process N, which is good. Okay, connect DB, and if you have a cached connection, you're returning that. If not cached, not promise. Okay, URL is here. Which company? Okay, you want to know the company? Just give me a minute. I'll be back. Okay. I had a phone call. I'm back now, and which company you're asking me? So I work at Oracle right now. This is a cool project, by the way. This is a nice project, but if you want to learn more, I would suggest that you use less of the AI stuff and try to do it on your own. Okay, cool project. Okay, I'm going to continue with my stuff. If you have any questions, you feel free to ask. Odin is a manual memory management based language. This means that Odin programmers must manage their own memory allocations and tracking. Yeah, we went through this thing. You have an allocator, you can give it here. By default, the context stored allocator is a OS heap allocator, and temp allocator is assigned to a scratch allocator. The following procedures are built in and also available in package mem with enforced allocator errors and are encouraged for managing memory. We have new int. Okay, this is a pointer. Okay, pretty decent stuff, I would say. Tracking allocator. I'll move onto this section. Logging system, foreign system. We are not interested in this. Okay. Let's run through how we could use vendor GLW library. Quick, okay. Mm, right, and I think we are pretty much done with the documentation. Is there anything else which is interesting? Let's see this thing. Arrow operator, select call expressions, and yeah. So, do we have some other things in the chat? No. So, FPS highlighted 26. Are you still in the chat? You said you're a dev student. So, in which year are you? Mm, okay, this is some stuff which I don't think we need. Let's see basic idioms. These idioms will probably be interesting. Uh, mm, yeah, I think we are almost done with the basics of this language, what all constructs are there, and now we can probably from the next live stream start building some projects, start building some pretty cool things. And yeah, that's all for this stream, and thanks for watching. Bye bye. See you all.